actually. Now, getting into my favorite subject. Software architecture. Game reference here, anyone? Any old school gamer? How to get ahead in... yes? Sorry? I was from Monkey Island. How to get ahead in navigation, if someone remembers how. I'm an old school game kind of geek. Yeah, that's a quick presentation about me now, finally. Consultant, worked on some larger web systems. For example, in e-commerce, I run a quite large web shop in Sweden, done some banking software, social platform, like a forum discussion platform, so people can create their own discussion forums. So done for the last year. I started Haxe as a way to escape PHP, basically. I was so happy to find that Franco just wrote the PHP target, and that was my rescue. And I'm kind of a tool maker, so I was making Haxe Igniter very briefly after getting into Haxe, just want to see it works. After a while, started to work with Franco on UFront and Eraser, and I did a few other, Inject for dependency injection, UMock for mocking. Then I took a break for a couple of years, and then I realized that Haxe has this, one of the few languages who has this possibility to make DCI. So I was all into it again. Now I'm here for good. And I also made these contracts that I show now, of course. So let's get right into it. I want to start with the roots of programming, so we don't forget what we're really here for. I mean, when the computer appeared and people start to realize, hey, this could be quite useful, then people want to use it, not just programmers, those hardcore hole-punching guys. And in the 50s, Fortran became one of the popular languages, and Fortran stands for IBM Mathematical Formula Translating System. So it's about translating formulas to something that the computer understands. Basically, mathematicians, they wanted to talk to the computer. In the 60s, COBOL was the next nice thing, because now business and finance want to talk to the computer. So this is a business-oriented language. So we have formula translating, we have business-oriented things. So what this really is about, those languages, is about mapping from one language to another. That's what we really want to do. We want to speak in one language that we like, and the computer should understand it. Then came the 70s, and research shown that let's see what I wrote here. Yeah, this mapping that I talked about is very well expressed using mental models, because people, they think and interact naturally with objects, and we can use those objects. I mean, it's any object. We can use those as building blocks for mental models, and there we have object orientation. That was the start of everything. So a mental model is an explanation of someone's thought process about how something works in the world. So for example, we take an old phone. When you want to design this phone, or if you want to explain to someone who never used it, like a young person probably never used this, you just have an explanation for it. And it could be like this. This is any kind of explanation works. That's a mental model. And you see here, we have a object terminology, we have a receiver and a wheel. And we have a function, which is to make a call to someone. And it's based on a form. The form is the phone and all the objects. So we have function and form, which you probably noticed it if you studied any kind of design, interaction and stuff. Function and form is very important. and mental models. But let's focus on this for a while. Form and function, it works in practically any case. I will give you a simple example. There is a wasp inside your room, and you say, okay, I need to get rid of this somehow. So your mental model could be like this. I need a container to get this wasp out. And the container, well, it has form, right? We don't know the form really. It's kind of blurred when you think of container. So basically anything that fulfills the form of container works. I mean, it can be an ice cream box. It could be very useful. But it can also be grandmother's very expensive crystal glass. It doesn't matter because the form is the container. The form is of a container, both of them. And using this, you can actually do this function that you want. You can get the wasp out. So the form enables the function. Two interesting concepts, right? Let's go back to mental models really quick. It's very important to match the mental model. Yeah, see some smiles here because you may recognize very good game. What's happening here? Yeah, X-Wing. This mental model of this game match, you have a joystick, few simple keyboard commands, and after a while, the objects you control becomes an extension of your mind. You don't even think about moving the joystick, pressing some keys. I mean, you're piloting an X-Wing. That's the amazing thing about a good mental model match. And the same for civilization. After a while, so into the game that you're the ruler of a civilization. Control all those units because it's a match. So matching this it's basically essential to make the users understand and like what you do. I have an example of the opposite. It feels like you're directly manipulating the system. That's what you do when it's a match. Then we have maybe a mismatch. I think you might have used a certain word processor, and maybe you want to drag a picture, and you say, I want it to be exactly here, and then and some space, and shit, what happened? So it's a bit of a problem here, right? When the mental model mismatch, you kind of lose control. So the programmers or the designers of this, they clearly mismatch the users. And it's not good. It basically will make the program unusable for you. You may stop using it, use another one, and yeah, that's a problem for the software. And a funny thing here, that all the unit tests probably passed in this software. Yeah. So now it's back to unit testing. I want to quote Dijkstra here. He said that testing shows the presence, not the absence of bugs. And it also shows that you cannot hide bad architecture behind a great user interface, because the architecture doesn't allow, no matter how fluent and nice the user interface, the architecture doesn't allow what you want to do. So more unit tests won't help either, because we want the whole system to work, not just the methods or some objects. It's more than that. So now we finally arrive at system. The definition here is set of interactive components forming a whole. So we have, let's do a recap here. We have those objects with a form. You can have different types of function. You see the form of a glass, for example. You can drink wine from it, but you can also play it as an instrument, because the form is very versatile, it seems. Then we have mental models with our thought processes about the behavior of these objects and their functions. So just to define some terminology, maybe we can call all this a system, and the form of this whole system, the architecture. Sounds okay? Early in computing, actually, people wanted to implement this. I mean, these are real-life concepts. They want to implement this into computing, so the machine should be thinking what the individual is thinking, not the other way around. So that was the start of it, and it was a good idea. Then some things may have gone wrong, and I'll get back to that. Now, let's finally do some code here. We want to design a system, and we're doing it with, let's see what we have here. We're making a digital ordering system for restaurants. Thinking about an example, I think this can be useful. So, in a restaurant, you can have some kind of handheld device, and you should use it for anything. In this case, when serving food, chefs just maybe signal that something is complete. And just for fun, the last one, it should also be used for when the manager pays salary. I want to make this example a bit more complex so you can see some things happening here. And the first step when designing a system, after some initial concepts, you have to have like a basic concept, the whole thing. You start with a domain analysis. And unfortunately, I have to rush this part a little because we don't have much time, but when you do domain analysis, you basically find out the basic of those objects. What are the real objects we're talking about here? And what are their properties? Not what they do, not the functionality. So you probably speak to some product owner or client, and he says, well, you talk to him, you say, oh, it's important that we have a register with name and birth date. You say, okay, could be a good foundation for the whole system because it seems like there will be employees doing all those things. So you can make a really simple class, and from there you say, okay, there can be, let's say we have a waiter, we have a chef, and we have a manager. Let's ignore the customers for now in this system. So you create just classes for them, and yeah, let them extend the employee. And now we get some more business information, of course, and let's see what we can do with our object-oriented toolbox to see if we can actually design this system with our current tools. We have a mental model, which is the actual functionality here. So this guy who is very into restaurants, he knows exactly how it works. I think you may know this too, but he said that, okay, this is my explanation, and if we can express this in code, it will be great. I mean, he would be happy. We can reason about the whole system, so it would be great if we can implement this mental model into our architecture. So the first part will be inheritance. So you keep discussing with the customer, and he says that, okay, the manager, he can also be a chef and a waiter. You say, okay. So you start to implement some method for that, but then some other requirements come up. The chef refuses to deal with the customers, and the waiter, he cannot cook. So if we want the manager to do all the things that the chef and the waiter can do, we kind of have to push those methods up into the employee class. But then we have some problems here because the waiter should not be able to cook, and according to this, he can. So there may be a problem with just pure inheritance. And really, we cannot afford to lose this business information here. We want to express this in the architecture. So inheritance, simple inheritance, may be some problem here. Even if we go to multiple inheritance, now we pretend that Haxe can do it, and we just keep extending. Then we get another requirement here that, of course, not all managers are chefs and waiters. Yeah. So we need to start to distinguish. We will make a chef manager. And after a while, it's like, okay, let's add more employee types, and we have like a really huge class structure, which, yeah, and how to instantiate it. We have to somehow keep track of who is what, and this can quickly turn into a mess. So in a way, maybe it's good that we don't have multiple inheritance. So okay, that's part one. Part two, interfaces. Let's try that instead. We make an interface for each here. We implement those, keep going. Oh, damn it, now we're back here with the chef manager. And now something happens here. I mean, this code, this is not a beautiful form in architecture. If you look at this is really beautiful. The code we're looking at looks more like this, right? It's like we're focusing on the structure, not on the architecture. And that's what we want to do the opposite. We want to capture the form of the system, not the structure. I mean, as engineers, we may like structure very much, but we code mainly for others. We cannot forget the users. Our goal is a happy user, not a happy engineer that can discuss all the cool features of this structure, right? So interfaces may not be the correct place for architecture on this level. In other words, the system form that we wanted, those simple requirements of the customer, it's not a representation here anymore. This is only about engineering. And now let's add some patterns to that. And you know, it'll be even worse probably. It'll be even more abstract, and we have layers of indirection all over, and yeah. So eventually we will end up here. This is the world, right? We have a great multi-butt supporter here. Yeah. So the problem, as you may have understand now, that programmers, as including me, of course, we're kind of preoccupied with technical excellence that nobody but us understand. And I mean, we put the structure before users again here all the time, and it doesn't make sense. If we want a successful project, it must really make sense to everyone. So you may have been in this situation. You talk to someone in the same project about stuff, and you say, oh, this object, yeah, this is an indoor session in initializer because there is a session that counts the number, blah, 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 blah. You start. Basically, this is a nerd forcing his model onto the user, not the other way around. This is implementation level, not architecture. I must say, of course, that design patterns can be useful, but on a lower level, not on this level. You should focus on users here. Of course, there are patterns that use to align this user mental model with computer, like MVC. I will talk a bit more about MVC and how it connects to DCI. Let's try one more, could be popular way of doing things, using services. And if you make a simple service, you basically make an interface, implement it somewhere, and you can have a service locator. You get the chef from somewhere, and you just tell the service to cook food, and you pass in the chef there. And this turns into an all-knowing imperative method. So we're basically we're not doing object orientation anymore. This is top-down procedural programming, right? We're trying to do object orientation here, not BASIC or Fortran. So we want the chef to cook the food, not some service. And we cannot forget that the business information we had in the beginning, we don't want to hide it behind interfaces. We want it to be quite obvious in the architecture. So services may not be the perfect thing either for architecture. Now, now there may be a solution. DCI stands for Data Context Interaction. I will try to do my best to explain the separate parts and then how they connect together. Just a quick display of the inventors here. The inventor, the main guy is, or the first inventor is Trygve Renskog, who I think you know him in some way because he invented MVC. So he knows what he's talking about, really. He's been around since the 60s, where he started to write CAD software. And the co-author with him is also an amazing guy, James Copeland, who wrote his in the C++ world. He's a kind of a legend there too. And he really drives this forward with precision. If you've been inside talking about patterns, Scrum, Agile, he's probably mentioned somewhere. So what I want to say is this, that these guys know what they're talking about. I mean, for 10 years now, they've been really formalized DCI on a level that surpasses most other software patterns I've seen. So I just want to say that DCI is not a whim that someone blogged about last month. This is solid stuff, really. What DCI postulates is two things, data and function. So we have this simple employee class that we created in the beginning, which is data. A real dumb object, really. It knows about its own stuff. It doesn't know anything about the outside world. And then we have functionality. We know what this system we want to design. We know what it should do. And we can structure it a bit different here. We know what the chef should cook food, the waiter should do, and what the manager should do. So what do we want to solve here? Somehow we want this employee to become one of those entities, or whatever we call it right now. So the thing we want to do, if an employee object could somehow attach this cook food method, and could be chef, right? Because then it has the functionality for becoming a chef. And this is an interesting thing about objects in general, that objects seems to be more than a class. We cannot do this with classes only, as we tried in the first three parts before. So it seems like a more dynamic operation. We want to compose an object for more than classes. So basically, what we have done for the last 20, 30 years is class-oriented programming. Objects are more than classes. It's getting obvious here when we see just the limitations, but also the functionality maybe should be separate from this simple class. So if we take this employee object, add a function to it, now this is very important. Now this employee object can play the role of a chef. This is a good concept, and it's essential to DCI. I mean, it's similar to traits and extension methods and mix-ins and whatever you have here, but this is more central as you can implement maybe roles using traits and stuff, but a role is a bit more than that. I will show you soon. So this object has this cook food function. Now it's a chef. And later in the program, same object. If we take this cook food method, just remove it, and we add pay salaries. Now it's a manager. So it seems that using roles, we can really express this architecture that we wanted from the beginning. Roles and context. This is one of the parts of DCI. A role is only relevant in a specific context. This is very important because traits and stuff, you know, they can be all over the place. They're kind of global. But when you think about it, cook food is only relevant in a specific context. There's a big difference between cook food and cook food, right? As soon as you take context into consideration, and we're always inside some kind of context, then we realize that, okay, roles should be bound to context, not just free-floating like traits and extensions are. And now we're getting to the interesting stuff, because a mental model that we talked about in the beginning can be represented as a context. So now we're starting to tie those concepts together that we did in the beginning, the mental models, form and function. So we can express this mental model we had at the beginning using DCI. So let's do that. We still have this simple class which is the data in DCI. So we have data, and now we remember we cannot put the methods in this class. They should be attached by some means. So where do we put the functionality? Of course, we put them in a context, which is this context, the mental model, which is also the functionality. So now we start to see the picture that this is all about objects, simple objects, doing functionality within a specific context. So now we start to separate in a very nice way the functionality from the original objects. And we want to do this. And you see here we have highlighted the roles here, which is a waiter, guests, and a chef. And using my Haxe DCI library, we just implement them like this. Just add a keyword and empty block for now. And now we want to map this mental model to code. And this is a fun part. And a good way to displaying this is to use a sequence diagram. This should really be the last step. I mean, the actual implementation or how to formulate this algorithm should be done by communicating with people, not just writing a diagram and send it to someone, because information will be lost there too. We need to talk to each other and really discuss this, think about this. So I jump ahead a bit. So we need an entry point anyway to this. So the first thing that happens to actually start this context is that guests are arriving. Sure, they do. And then this mental model should happen. So the first thing that happens is that the waiter walks up to the guests and shows them the menu. So you say, okay, let the guests select from the menu. And then what happens? The waiter here takes the order, passes it on to the chef. He takes the order, passes it on to the chef. So the chef cooks the food, right? And after that, the food is brought out to the guests by the waiter. So the waiter serves the food. So with DCI, this is what we want to do. We want to capture the runtime interaction between objects, which is real object orientation. This is a network of communicating objects. So for the first time now, we have actually runtime interaction between objects. We can actually see this happening before it happens. I will get back to that shortly. I will just display how it works right now. This is the current object-oriented way of creating object communication. We just pass messages wherever and whenever we want. Yeah, here's an event. Oh yeah, it's basically, it's mess. It's too chaotic. And we don't separate any data and behavior here. We can only see one object at a time. I mean, when we do polymorphism, we have no idea to know where we're going. It can be any object in the whole inheritance chain. So reasoning about system behavior, reasoning about the class could be okay, but about the whole system, very hard. Another way of doing it is the procedural thinking, and you can do it as the mediator, which is just, we have an all-knowing object here who he knows everything and he tells all the other objects what to do. Now we're back to this. We're preventing object communication here. Now we're not object-oriented anymore. This creates a complex all-knowing algorithm. We're stepping back again to Pascal and Fortran. We don't want to do that. So what we can see from this is that things won't self-organize simply. No matter how many layers of indirection we have here, it just won't happen. More patterns won't help either. It will be chaotic. And this one won't make things easier or more object-oriented either. So we need a middle way, really. And DCI actually gives us that way. because now we have distributed logic encapsulated in the context. We have the functionality here, and the objects talk to each other. So we can see what happens at runtime. We still have state and behavior, as in any object-oriented stuff. Now we have a network of collaborating objects. And this last one, it's so amazing. Now we can reason about system behavior at runtime. This runtime interaction. And the thing about this, where did we have to go before to see or actually reverse engineer runtime behavior? What did we have to do? We have to debug, right? But now we don't have to anymore. We can see runtime behavior before it happens, contextualized. It only took 30, 40 years, but now we're here. Yeah, kind of exciting, I must say. Let's keep coding. Yeah, I don't know about time, but I will try to be quick about this. This is how it works with libraries. So this is also a real implementation. Now, when we want to instantiate this context, we want to. It's called binding binding objects to those methods here. So when we create this context object, we pass in an employee, another employee, and we can make it a list for the guest. It doesn't matter. And then using some macro magic, of course, I create some fields for those roles here, and we just assign them. Thanks to Haxe great type inference, we should not even specify anything here, any type. It will just happens. Really nice. And we need this entry point. You remember the first entry called guests arriving? Basically, the only thing, you can treat this as an event. Something happens, guests are coming, and the only thing this system operation should do is start an interaction. And the first part, you remember, of this sequence diagram is that the waiter something is happening in the waiter when guests are arriving. So we do that by, now we start to implement the functionality within this role. It was empty before, just empty brackets. Now, let's add it to the waiter. So guests arriving. And this is, now, finally, we're at implementation. Here we can start to talk with this handheld device that we're supposed to use. But for now, we can keep it simple. So now we just let's make a string menu, and we move on to the next step, and this is important. Now there is no return values, we're not going back anywhere. We just tell the next step of this mental model, which is that the guests should select from the menu. Okay, let's do that. We take our guest role, and we just keep going with the functionality. So to keep it simple, let's print the menu, let's read the key, and let the waiter take order. Just keep building this mental model, now for real. And, okay, the waiter should take order. Let's add another method to the waiter role. So say, okay, thank you, and just pass it on to the chef. Let the chef cook this order. That's how we build it. Quite simple, huh? Good. And just a quick thing about different system operations. In the end, there will be a break in this mental model because the guests arriving, okay, after a while they get the food, and now this process stops because they have their food. There will be some time before they finish. And when they finish, they go back to the same context object, which is still alive, and they will say, okay, we want to pay. And then we can just keep going with this mental model. So the waiter will have more methods in it, but it's still in the same context. So this is a very nice encapsulation. Let's speak more now. I'll get a bit more technical. A DCI role, it has a role interface and role methods. The methods we already know. It was what we did before when we implemented, but there is also an interface, which is actually what is required by this object to play this role. Because usually, you see here, when the guest arriving, we want the waiter to tell their name to the guest, usually in a restaurant, which actually requires a name of this the object playing this waiter role. And because our employee has a name, it can be a waiter. So this is like an interface which kind of disconnects the context from any object. So any object playing this playing a role of a waiter has a name. It's possible. This is a nice way of making many objects playing the same role. A classic example is a spell checker in a word processor. If you want to spell check something, you don't want to spell check just one word, you want to spell check a sentence, you want to spell check a whole document. So the logic for that should really be in a context. It cannot be in a specific object that is tied to that, and it's perfect for any object that can play this role of something being spell checked to just be implemented here and just add it to the spell check context, and things will kind of sort it out. And going back to the first example, it's the same thing here. This is the connection between real life and the code. The form for this container matches the role interface for this role container in the context remove insect. You see, there is I think a wonderful mapping between real life concepts and code with DCI. One last thing here. Now it's a bit more technical. The execution model for DCI will be different because those methods should only appear on the object when they're inside the context. So if the program counter goes outside the context, the object should not have those methods anymore. So we need this role keyword to actually specify that as soon as an object is bound to this role, they should have extra methods dynamically when they're inside the context. And you cannot do that real easily in many languages today, but using macros, no problem. So you can emulate this execution model using macros. And there is also another keyword, context, which is always pointing to the currently executing context. So all the role methods have access to other roles, so they can actually talk to each other. In the current context, it's very important. And now, the most important part. Object identity. It must be preserved. Not equality, but identity for the object. And this is where composition actually fails. Because some people may say, oh, I can just use another class for the roles, and that will be it. But you cannot, because then you break object identity. Which can give problems, for example, if you use a third-party library, and that library is using identity checks. I mean, 3 equal signs in JavaScript, for example. Then you may assign an object, and if you use a wrapper solution, then it will point to the wrapper, and the third-party library will fail its object identity check, and you have some very subtle, almost impossible to find bugs. So you need to preserve object identity. Self here should always point to this object, not some wrapper containing some methods and maybe a reference to this object. It's not possible. It's not valid in DCI. This is also another thing that makes it hard to implement in other languages. But still no problem with macros. So we're at the end. So I want to make a summary what DCI is. So it's a way of reflecting the user mental models in code. It's also a way of separating what the system is, which is the data, which change very slowly, compared to the function, which change very quickly. I mean, you may have noticed that this employee class has been sitting up here all along, very simple, never changed, and still we can do quite advanced functionality based on its simple form. just the name, and it can be waiter and things like that. So this is a great way of separating different rates of change in a program. And one thing I forgot to mention, that inside those role methods, there is nothing stopping us from actually instantiating a new context, which is based on a different mental model on a different level. So down here we can create a mental model for the programmer. And now we're actually slicing behavior at mental models, which is great. So we have a high-level thing, high-level context for that the end user understand. And then we go here, we can go into a low level that the programmer understand. Because there will be different terminology, there will be different rates of change. So I think it's a great great point of like an abstraction boundary. DCI also allows us to reason about the correction of the functionality of the whole system, not just simple classes and methods. And the polymorphism is gone because of all those role methods. We know that when we execute something, it will be inside this context. It won't go to any class that may be any other class. So I mean, James Copeland, he said that virtual methods, there are like intergalactic go-tos. And it may be true if you have a large inheritance chain. So finally, we put behavior back within the boundaries of a human mental model. We don't spread it across classes, services, patterns. Humans can understand things again. And I think when you remove the comments like here, it's not too much code either. So that's it basically. I think we have a way now of actually start to delivering value instead of more classes. And I think Uri said it very well yesterday in his talk. He said, trust your fellow programmers. And I think I trust you to do what you think is best. So the future DCI, I trust you. Yeah, that's it. Thank you very much. Okay, any questions? This is my moment of fear. Sorry.
Hi.
Hello.
It's an interesting point of view. Don't you think it's very to me, it's very similar to swapping delegates at runtime, something like that, and defining the behavior of the object within the delegate itself?
No, that's too low level, I think. This is about high architectural concerns. Implementation about delegates and stuff, this DCI doesn't concern it very much. So this is more like connecting mental models. It's about users, not about specific implementation.
Yes, but you are defining the behavior of a waiter, a chef, or whatever,
yes,
by passing along an employee.
Uh-huh.
So if an employee enters the restaurants, he can be also a guest, for instance, mm-hmm. or he can become the chef while he enters the kitchen.
Yes.
So the context is the restaurant or the kitchen. If you define the delegate, which is the function that has to be, or better, the role in your case, that has to be interpreted by the employee, that could be something like a subclass of the context.
No, it's more like a mental model. You have to see the context as a mental model. So what happens in there and the interactions, it's more like the functionality. I really try not to mix implementation with this DCI high-level stuff.
Yeah. I understand that it's much more about focusing on the problems, on solving the problems the business problems, let's say, instead of focusing on the implementation.
Yeah, that's.
But we have to code the implementation. So
yeah, well, I have a hard time to see that this kind of architecture should actually be in the way of implementation. I think that this kind of architecture should actually support the ever-changing implementation that should be. It should support it, I think, better than any other architectural pattern out there.
I'll give it a try, definitely, because I'm very interested. The second question that I have is, how don't you lose the static typing of the objects by doing these things?
Static typing where?
Anywhere. I mean, you are defining a role with a macro, which gets compiled after compile them.
Yeah. Right. Now I understand. Well, using macros, I take this role interface and I basically make the field into this role. I make the type of the field this role interface, and then when you instantiate the context, then the type inference will just handle everything. So yeah, it's really nice.
Yeah, cool.
I asked you this on Friday, I think. Like, what's the particular advantage of nesting this into the class of that syntax? Because I would think it would be much easier to use an abstract type. Because if you need, then you can actually reuse a role in a different context. Like, can you do that second thing, like have the same role in a different context? Because
no, you couldn't. If you remember this example about cook food.
Yeah.
If you cook food in a restaurant kitchen and in the outside, in the outdoors, it's very different. So it's actually a basic property of roles that they cannot be shared between contexts, because the context will always be different. The roles will always have different behavior inside the context.
Well, you can't say that for sure.
Well, it's most of the times. I mean, it's also on a higher level.
Basically, your assumption is that this is an edge case, and that should it ever occur, you just have to copy paste and live with it. And
yes.
Okay. Cheers.
Yeah. And I also can answer your first question about abstract objects. My first implementation was abstract objects, which worked, but then I found this is a bit more readable, and it's also more. It's better to contain the roles within the context, because mentally they're already there. So I think it's nicer than to have a context and then below many abstract classes defining the roles. So I think for readability this is nice.
That's interesting. First, a general comment, like when you separate data from operations, somehow that's what functional programming does. So can you still call that object-oriented?
I think so, because state and behavior is, it still belongs to the object. And the identity is never compromised because of this. So.
So somehow the object, you introduce something new, which is a role, but it's not really an object, because, it have a contract with the interface you have, but, it's no longer somehow tied to the object, but more to the context. So it's kind of, you have a set of operators in your context, and you have data. So for me, it seems a bit more near than from functional programming actually than from object programming. But okay, this is just a semantics discussion. Just a question: what if you really want actual? That's maybe a second question. But what do you really want? For instance, actual polymorphism. For instance, what do you want to emulate a French waiter that don't say hello or something?
Well, you can have it outside the context, that's no problem. But inside the context, thanks to the role methods, there won't be a polymorphism unless you call outside.
Yeah, for instance, what you want to have a specific version of your context that that behave slightly different, but not entirely different. I mean,
sure I
can you subclass your context and override things?
No, you cannot. In the same way that you cannot subclass a mental model of a user either. It will always, because the context is more of that. It's more on that level. I don't think you should maybe regard it as a class or something. More like a concept that someone has.
Yeah, I got it. But I feel that, for instance, well, if I make games and you have kind of monsters and they all have common points, and then you have. It's difficult to modelize these things, I think, using DCI. When you have like you want to share code, but you want to. It's like difficult. Yeah, it might be very valid for quite complex entire object operations, but for kind of own behavior, behavior your own in all sense.
Yeah.
It may be a bit different. I don't know.
Yeah,
maybe I have to experiment more with it.
Yeah, sure. I mean, of course, the implementation can be anything you like. Behind this is like the overarching architecture. So below it can be functional. It doesn't matter much. It's up to the programmers on that level.
Anybody? Okay.
Hi. Have you thought about how you would deal with asynchronous stuff at this level?
Yeah, I don't think it concerns DCI much either.
Because in the example, the waiter takes an order, so it's sort of a blocking operation.
It
Maybe.
be anything on that level. You can. I'm sure you can just pass it on onto anything.
Promises?
Yeah, promise. Oh, definitely. I use promises in one of my examples, so it works.
Yeah, I understand it will work, but just how would you approach
the approach?
That sort? Yeah, how would you think? What is your?
Well, yeah, I would think asynchronous with the most passing between, because if you think message passing, I mean it's quite asynchronous. It's just an object telling another object to do this, and when it happens and how, then it's just, I don't know. it doesn't know. It's just an event, so maybe you can regard many things as asynchronous events. Does that answer your question?
Yeah, I guess.
Okay.
You have a question, I think it relates in some way to the other question, but it's how do you deal with context changes? So let's say, for example, one of the waiters is ill, so you just have to go home, and how you will deal with that?
Oh, it has to be expressed then in the mental model, what would happen when the waiter is ill, and you will make the object interact according to this mental model. Something will happen to it, maybe it will be replaced with another, you will have a role called replacement or something, and you will just keep on interacting on that mental model.
Okay.
What if the program is so much so complex that the mental model doesn't fit in your mind?
Yeah.
And that you can't actually make it write it off. So even think about it so much,
I'm not sure. I think on a user level, there are actually many working objects, so real life objects. So in a game, for example, user can always name something like this is a sword and this is that, and that will be the objects of the architecture. So I think it will be very concrete on that level, and I haven't thought about really abstract things and how to implement them in DCI.
For instance, what is your program you're trying to do? You don't know all the characteristics of it or all the roles. You don't have the whole picture when you start doing. You just keep growing, and it's maybe different way of, it's like it's great top-down approach, and what you want to do more bottom-up or something.
The context can be nested, right? I mean, you can. The context, I guess, they can be nested, so you can just create smaller sub-contexts that you can actually fit in your head, and then, just make a hierarchy. Yay!
Exactly. Yeah. Thanks.
Okay, everybody? No question? Thank you very much, Andreas. Allez, last question. Thank you.
Just one quick question. I know you don't like to write a lot of class, but what if, for example, a waiter can do like 1,000 action? I don't know, maybe a super waiter. Isn't that a bit too crowded in one embedded class? Can you just export that to another file and just add functionality?
Not sure I understand. A super waiter. What kind of would it be an object or like another class?
Yeah, I don't know. Maybe just a set of function, and you can just define those functions in another file and just add that.
If there is a place for a super waiter in a different context, then definitely you can pass a waiter in there. It will have all this super functionality you define. It will kind of be like Matrix actually. This is plugging into the Matrix kind of stuff.
Okay, thank you very much, Andreas.
Thank you.